Hello, everyone. Viewers, it is indeed my proud privilege to welcome you all to this wonderful dialogue in conversation with Stratview, wherein today we are discussing the only new product category entering the aerospace industry in the 21st century. Of course, the eVTOLs. This is me, Vyapak Tiwari, your host for the day, and joining us for the conversation are two very distinguished individuals. We're honored to have with us today Dr. Mansur Celebi, and an accomplished aerospace engineer and composite specialist with a distinguished career spanning military, academics, and also the cutting edge urban mobility development. Dear viewers, Dr. Celebi began his career in the Turkish Air Force, where he served as the head of aircraft structural engineering, leading critical airworthiness projects and structural upgrades for jet aircraft. His technical expertise is backed by a PhD in aerospace engineering with Boeing supported research on advanced composites, as well as a master's degree in computer engineering, holding a rare blend of material science and computational expertise. Dr. Chelby also served as the Deputy Director of the Aeronautics and Space Technologies Institute and held the position of Aviation Safety Technical Manager and Aircraft Accident Investigation Board member within the Air Force. After this, he transitioned to Sabancı University's Composite Technology Center of Excellence, where he still continues as Strategy and Business Development Manager. Also, he's the Chief Technology Officer and partner at AirCar, with his unique perspective from military airworthiness to academic research and development, and now eVTOL commercialization as well. Dr. Chelibi is perfectly positioned to discuss the intersection of advanced composites, certification, and next generation aircraft design. Welcome, Dr. Chelibi.
Thank you, Viapak. Thank you for this kind introduction.
Yeah. Also joining us today is Mr. Deepak Agrawal, a well-known market research consultant with over 15 years of experience in global mobility and composites industry. Holding an MBA in marketing and finance, Mr. Agrawal has led more than 200 strategic consulting projects and worked on 200 plus syndicated market reports across various industries. He has worked extensively in advanced materials, especially composites and chemicals, across sectors like automotive, aerospace and defense, oil and gas, construction, and recreational goods. Throughout his career, he has driven projects for both small firms and Fortune 500 companies, collaborating with many leading players in aerospace and composites. Today, Mr. Agrawal will provide critical insights into the global eVTOL market, sharing data driven forecasts on this competitive landscape. Heartiest welcome to this dialogue, Mr. Agrawal.
Thank you, Vapak, for the nice introduction.
Okay, so before we dive in, a quick note for our viewers. Viewers, make sure to drop your questions and thoughts in the comment section. Also, if you're a part of the aerospace or composites ecosystem, give us a wave in the chat because it's always great to see peers from across the value chain. And now, let's set the stage a bit. The world of eVTOLs has brought together aeronautics engineering, sustainability goals, urban development, urban planning, and next generation materials like never before. I think it's a rare convergence of innovation, and today's conversation is about connecting those dots: technology, regulation, commercialization, and beyond it. So, with that, let's get started. All right, so Dr. Chelebi, to begin with, let's take a step back and look at the big picture.
Okay.
The eVTOL industry, as we all remember, was just buzzing with excitement around 2020 and 2021, right? Constant media coverage, sky high valuations, flood of venture capital.
Yeah.
It genuinely felt like we were on the brink of a new aviation era, right? But fast forward to today, and the tone has clearly shifted. Most players in this space are now facing delays, especially around certification and commercialization. So, Dr. Chelebi, how do you assess the current state of the industry? I mean, are these setbacks part of a normal maturation process for a disruptive industry, say, or do you think they signal deeper structural challenges?
Yeah, it's a good question actually to start, and also thank you for the kind invitation for to join this important webinar and providing me the opportunity to share my insights on
Yeah,
the evolving eVTOL industry.
we are
I
really.
think everyone is curious about what's happening and what will be the possible progress in the eVTOL industry.
Yeah,
I would like to first begin by highlighting that eVTOLs are no longer a distance concept. they are already entering our lives, and soon they will start to play an increasingly integral role across various aspects of our daily mobility.
Okay.
And the eVTOL industry, it's currently in a state of transitional phase from prototyping toward the practical realities of commercial deployments.
Okay.
Uh, yes, there are some delays in certification and operational timelines. They are disappointing, but
Okay.
they are not entirely unexpected. We were expecting those delays.
Okay.
As you know, eVTOLs falls between traditional aviation and new aerospace segments. So regulators like FAA and EASA, they are having to create a new certification frameworks, especially for novel propulsion systems, autonomous flights, flight control systems, communication and navigation systems. And also, one of the most important one is safety and like crash avoidance systems, collision avoidance systems. That's why the safety requirements are understandably they are tight and meticulous. That's why the certification may take years, not months. If you talk about the technology, battery tech has improved, but the energy density still remains a limiting factor, especially for range and payloads. Integrating autonomy, redundancy, lightweight materials, and noise reduction remains a massive system engineering task. And on the other hand, lack of vertiports, charging station, unmanned traffic management system, it is slowing down the adoption. This is another reality, actually. That's why building an urban air mobility ecosystem, it's not just about the vehicles, it's also integrating those subsystems into complex urban environments, urban ecosystem, urban air mobility ecosystem.
Okay.
And all those research and application integrations and testings requires huge capital investments with longer lead time to cash generation. You know that early market projections were more than $1 trillion by 2040. And I still believe that by the year of 2040, we may reach those amounts. We still have 15 years. However, the strategy about paving the way should change a little bit. This is my idea. Currently, the space is crowded with dozens of companies, and many will struggle to survive once the reality of certification, manufacturing, and scaling up hits. There are also some concerns about public acceptance in terms of safety.
Yeah.
I think if you demonstrate safe and reliable flights, everyone will be willing to ride the air taxis.
Yeah.
And in short, many of the delays are consistent with what we would expect in a new aerospace category.
Yeah.
Usually, a new aircraft's development, it takes about 7 to 10 years of development and certification. And eVTOLs are no exception. And also, there are some legitimate concerns about how many players can survive, whether the business models are truly scalable, and how long will it take for the public trust and infrastructure to generate. That's why, if you look at the industry strategically, this is the shakeout and consolidation phase. We are moving from can we build an eVTOL to can we scale it reliably and affordably phase. And that's why the eVTOL industry is transitioning from conceptual development phase to the practical implementation phase.
Okay.
And you can consider, for example, electrical cars. People mostly purchase those electrical cars for commuting to the job or urban mobility, not for the intercity travels.
Yeah.
Therefore, urban air mobility phase, I think it must start from the simple design for urban mobility, not in the city transportation between intercities. Uh, this is what we should start, I think, at the beginning.
Okay. That's exactly what the OEMs are
Mhm.
saying that they're targeting right now. So, in your response to this answer, you've mentioned many challenges, right? You mentioned safety, you mentioned noise, You also mentioned infrastructure, right? But this was a very insightful take. And when we're talking of challenges, right, I want to now zoom in on the financial side of things, because that's where we've seen some real turbulence recently. So some leading names, of course, like Lilium and Volocopter, have encountered serious financial trouble, while Lilium even seeking bankruptcy protection for the second time. Now, that I think is a
Yeah.
big deal. So, from your perspective,
Unfortunately.
yeah, from your perspective, Dr. Chelabi, where do you think things went off track? Was it primarily poor financial planning and underestimation of the regulatory hurdles, as you mentioned, or is it more about external market dynamics, like investors pulling back from the capital heavy mobility ventures?
Uh, it's very sad to see those companies to have some financial problems. But I think the answer lies in the combination of factors, not just
Okay.
one factor.
Okay.
Uh, Many companies has its own context. It's still similar challenges faced by Lilium, Volocopter, and other companies also they faced. But these are the pioneer companies in eVTOL industry. We should know first that aerospace is hard and much harder than other traditional tech startups. That's why we should start with the simple design. Lilium, in particular, they pursued a very ambitious ducted fan jet design, which posed greater aerodynamic and thermal challenges when we compare to simple multicopter style aircraft. And
Okay.
of course, they have their own advantages like low noise or long range. They have long ranges. However, with the high maximum takeoff weights and ducted fan jet, they created some complexity in their technology, and this caused huge investment and longer time to certifications. And certification authorities, they didn't know how to actually certify those type of complex eVTOLs. When we consider Volocopter on the other side, they have 18 rotors over 11-meter diameter of rim, and those designs may have their advantages, but they are extraordinary designs. You cannot, for example, let them take off from uh, in an urban area. You need a special workforce for those models. That's why they got both Lilium and Volocopter. They face slower certification progress. It's not due to their incompetence, but it is a new category, and it is not an proved category in this case. And safety thresholds, it's very high, and every components of those design has to be tested, and
Yeah.
they need to have some redundancy as well.
Yes.
That's why if we start misjudging how long and costly it will achieve to type certification, it's going to erode the timelines or the patience of the investors. This is, I think, one of the
Completely.
cause. And another aspect is that building an aircraft and manufacturing line and the global air mobility network, they try to build all those at once, and they have more than 1,000 employees without any cash generation. This is another strategy I think they avoided, and that's why they burned hundreds of millions of euros before even having certifiable prototype.
Yeah.
That's why capitalist intensive strategies without matching any capital discipline, it may cause some insolvency risk. We shouldn't think aerospace as a software as a service company. That's why they have huge capex and certification timelines, and it is long. And if you make mistake, it's unforgiving. That's why the primary, I think, problems is their design and their strategy, business strategy, and their having a lot of people, employees in their hands before those certification has started, before creating any cash.
Yeah. Lilium had, I mean, when we look at the numbers, Lilium had got around 1.45 billion US dollars of funding, and
Yeah.
now they have to lay off the employees. That's really sad to hear. Now,
And I believe that those companies, Lilium and Volocopter, when
yeah.
I've seen first their design, it was really a challenging design. I mean, within the city, you don't need to build an aircraft for intra-city travel.
Yeah.
Because in urban air mobility, the distances are around 10 to 15 or 20 kilometers,
Yeah.
most of the travel times. That's why if you are building a long range, you need to have a lot of batteries, you need a lot of energy density. That's why it makes it very heavy, and the certification will take very long time. That's why I think the simple design is the crucial point in eVTOL industry.
Okay. Simple design is the best design is the key takeaway from this answer, dear viewers. Thank you, Dr. Chelebi. And I think this brings us to a very practical question, especially for those who may be considering stepping into the eVTOL space. Now, since Dr. Chelebi, you have mentioned a lot of mistakes that's been made by these, eVTOL OEMs. So there are still OEMs and tech companies out there with prototypes, ideas, and ambitions to enter this market, right? So,
Yeah.
what would your advice be to these companies? And is now a good time to enter and prepare for the long haul, or would you suggest waiting until some of the key issues, particularly around certification, infrastructure, and financing, are a bit more settled? What do you say for the upcoming OEMs?
Yeah, timing is crucial and strategy is everything. If you want to enter this eVTOL industry right now, there are still some opportunities, but it depends a sharp focus, disciplined execution, and patience. That's why I can say that it's a good time to enter, but not for everyone.
Okay.
It's a transitional moment, and the market is entering its consolidation phase. That's why if you are an OEM with strong financial backing, like multi-year runway, and if you have a deep system integration and aerospace experience, and if you have clearly a differentiated strategy from the current companies, if you have simpler certifiable design and near-term use cases like cargo and emergency response cases, and if you avoid from long-range piloted air taxis, I think in dense cities, the target must be to just focus on the urban air mobility within the city for shorter distances. That's why if you are a OEM with a good design, and if you have strong partners like Arches with United, Joby with Toyota, it is
Yeah.
also very important. And if you have an agreement with supply chain, with suppliers, if you have a strong supply chain agreements, yes, it's a good time for you. You will enter the eVTOL industry, you will learn, you will partner, you will prepare before scaling up.
Okay.
But another approach may be you don't need to build an eVTOL. I mean, it shouldn't be a platform, but you can find the gaps in the eVTOL industry, like batteries, new batteries, or flight control systems, or maybe just you may work on structural point of view. That's why you can find the gaps in the eVTOL industry. You can, for example, just be a company for the vertiports or air traffic management system suppliers. That's why you should explore niche use cases. And there might be some eVTOLs just for medical evacuation, cargo logistics, or defense, even touristic purposes can be used. Those kind of things I think we should focus on. And we shouldn't actually, those companies, they shouldn't aim for the perfect air car, the air taxi, but they should aim for the certifiable and reliable design. And then they can do, later on, they can do incremental capabilities that can evolve after you completed the certifications. Once you get the certification, and then you can add some additional capabilities to your eVTOL. So another one might be using for dual applications like defense, emergency, and government mobility contract. This tends to have lower regulatory barriers. If you develop an eVTOL for government, the regulations will be much lower. For firefighting, wildfire fighting is also very important. That's why if you can have a stable funding and provide a proving ground for commercial evaluation, it is also possible for you to enter this market. And as I said before, partnering with aerospace suppliers and from the MOUs with regional governments to airport authorities, you should start a partnership with them and just not focus on the aircraft. I think we should invest in the ecosystem, like
Yes.
vertiports,
Yeah.
charging infrastructures, maintenance, flight control softwares, platform and services. It is also very crucial. And this is, I think, in short, what I talk about this OEMs.
Yeah, no, that is absolutely that is absolutely an interesting perspective. We have seen companies like Skyports, for example. So Skyports is doing good. They recently also collaborated with Dubai's authorities. They are setting up vertiports there. A company which is founded in 2018, especially to make vertiports. So yeah, that's really I mean not just focused on the being an eVTOL OEM, but investing in the entire ecosystem is important. That's the takeaway I take from this answer.
Exactly. Yeah, I
Yeah,
agree. Even the governments and municipalities, they should involve in this eVTOL industry development,
yeah,
especially
that's
for air traffic management system is one of the key, I think, parameter to success for eVTOL operations.
all right. That's really an interesting perspective, Dr. Chelebi. Now, shift. I would like to shift gears slightly to the material side of the equation, right, which
Mhm.
plays a very crucial role in performance, scalability, and also the cost, right. So,
Yeah.
Dr. Chelby, what I found out is that today over 90% of the eVTOL OEMs rely heavily on thermoset composites. But thermoplastics, with their advantages in high rate production, like repairability, recyclability, are increasingly drawing interests. Especially given the industries need to scale
Mhm.
efficiently. So, how soon do you think, Dr. Chelebi, how soon do you see a foreseeable viable transition to thermoplastic composites? And what kind of breakthroughs, whether in material science, automation, or regulatory approval, do you think are necessary to really accelerate this shift?
It's a good question, and it's a very timely question, I think. The shift from thermoset to thermoplastic composites in eVTOL industry is not a matter of if, it is when actually it's going to happen.
Yes. Yes.
It's eventually it's going to transfer from the thermoset to thermoplastic. But I think most of the companies, those eVTOL companies, they first want to certify their eVTOLs
Okay.
with the already certifiable materials. That's why they started to use thermosets. But eventually, due to manufacturability, due to, as you say, the recyclability, they will switch to thermoplastic. And the challenge isn't just about the performance, it's about the readiness level, I think. The material, the process, the supply chain, and the certification all need to be catch up. That's why, as you said, there are many advantages of thermoplastics. They have faster processing time. Thermoplastic can be welded, stamped, reshaped quickly, and that's why it makes them ideal for high rate, cost efficient manufacturing. Especially if in the future, we will have millions of maybe eVTOLs to be manufactured in a year. That's why you need high rate manufacturing materials. And unlike thermosets, they can be remelted, reprocessed, and they can match the sustainability goals.
Yeah.
And also, they have, from the safety point of view, they have the higher damage tolerance perspective. I mean, generally, they are tougher with better impact resistance and crack propagation behavior. They don't need storage. They don't need freezers like thermoset. That's why their storage and their transportation is much easier compared to thermosets. But when we come to material and processing maturity, aerospace qualified thermoplastics like PEEK, PEKK, or PAEK materials, they are still expensive and they are hard to scale. That's why I said that it is a timing process. I mean, a matter of time. That's why the availability of ready-to-use fiber reinforced prepreg is less compared to thermosets. And when we come to manufacturability, automated fiber placement, or thermoforming robotics for thermoplastics, they exist, but they are not still widely deployed or industrialized. That's why I think we need to wait for them to be widespread. And the welding joining techniques are less familiar to certifying bodies. I mean, the certifying authorities, they don't have so much experience in thermoplastics. This might be another bottleneck in. And when we talk about the FAA and EASA, they are still more comfortable with the legacy thermostat data.
Okay.
And in thermoplastic, we need longer-term durability, fatigue, and fire resistance data, and it will take time to accumulate. And that's why, since I mentioned that peak is very expensive still for the usage, but lower cost PAEK formulations to maintain aerospace grade mechanical and thermal performance is needed. And I know that people are still working on this technology, and better surface treatment technologies for co-consolidation and bonding, like plasma activation, pill ply chemistries. These are one areas that we should still doing research on it.
Okay.
And also manufacturing automations like standardized, scalable inline welding processes, or integrating inspection systems like IR thermography or inline computer tomography.
Okay.
It may create some safety standards for those manufacturing. Uh, That's why I think thermoplastic are ideally lightweight. They are modular. They have scalable vision for eVTOL aircrafts, and the shifts will be gradual. I mean, it will not going to shift very quickly, but eventually, even commercial airlines, commercial aircraft manufacturer, they will start to switch from thermoset to thermoplastic. And first, I think it will start with the eVTOLs. Once they are
Okay.
certified, they will start to switch from thermosets to thermoplastics.
Okay. Understood. Dr. Chelby, with that said, that in the beginning of this question, you said that it's not a matter of will it happen. It's a matter of it when, right?
Yeah.
So when it happens, when which specific components or structural parts in the eVTOLs are most likely to be adopted to thermoplastics first.
I think with the cabin interiors, we can start with the cabin interiors, or not structure critical parts will start with thermosets, but the other parts like cabin interiors, seats, or other parts that not structure critical will switch to thermoplastics. And I already manufactured those eVTOL structures. That's why I know that it's crucial to be able to pass all those certification test standards. That's why the parts that is not structurally critical, it will can switch easily to the thermoplastics. But the main objective of those companies are still certification. That's why they use thermosets. But later on, when the number of manufacturing and the scale up they switch to the scale up phase, they they need to go to thermoplastic. Otherwise, they cannot manufacture that amount of eVTOLs using just thermosets materials. It may, I think, within 2030, I say, after certification, it will start to switch from thermoset to thermoplastics.
Okay. Understood. We have a comment from Anna on LinkedIn. Anna
Okay.
asks, since certification authorities like FAA and EASA are not very familiar with thermoplastics as of yet, So, do you suggest that OEMs that are planning to enter the market should stick to thermoset-rich models as of now?
Already those companies, they have thermoset materials. They already have their own thermosets. That's why uh, you don't need to stick to the thermoset rich models. But eventually, everyone will switch to thermoplastics for sustainable worlds, for fast manufacturing methods. That's why I think most of the material manufacturers, they are doing research. I know that they are doing research and they are developing some thermoplastics. And the eVTOL OEMs also, they need to do some studies for transferring from thermoset to thermoplastics. And that's why they may start to have some agreements with those material developers for to be able to secure their supply chain. Because in the future it will be really very difficult to find or make those agreements when everyone start to need those thermoplastics.
All right, understood. Uh,
FAA also, I think FAA and EASA, it's a word, it's a challenging word, and when the OEMs and or companies, they start to use and they show that actually this is a safe materials to use in critical parts, they just check the results of those tests they have done. If they prove that, those OEM companies, they prove that it's a safe material to use, they are not going to object. The authorities they are not going to object
yes.
to those results, and they will accept that.
And rightly so, there should be no relaxation in aviation when it comes to safety for obvious reasons that we all know.
Exactly. Yes.
Yeah. Yeah. So thank you so much, Dr. Chelebi, for these incredibly valuable insights. Now, let's turn to the commercial side of the equation. And for that, I would like to bring in Mr. Deepak Agrawal. Mr. Agrawal, consulting firms have published widely varying projections for the eVTOL market, right? We've seen estimates ranging from hundreds of billions of dollars to over $1 trillion by 2040 as well. So that's quite the spread. So, given your hands on experience, how do you reconcile these disparities? I mean, beyond the noise of $1 trillion forecasts, what does your analysis tell us about the realistic commercial potential of eVTOLs, particularly when it comes to the actual market adoption?
That's, I think, a really good question. So, when we started understanding this market in a more comprehensive way, like we started understanding, what the startups are saying, like, if you talk about Joby, Archer, Holocopter. So they have been, showing a lot of promises in terms of commercialization, in terms of production rates. And when we started going into depth and trying to understand what's the real condition and how exactly the entire market system or market ecosystem will evolve, so things were very much different. I completely agree with Mansur points. Like if you want to have eVTOL successfully, launched or bring into the commercial aspects, so you need to address a lot of factors. Certifications remains one of those, but it does not like that certifications remains the major one, but you need pilots, you need good battery management solutions, you really need to address the noises being generated by these aircrafts. Also you need viability, like if you have eVTOLs, it must be competing with traditional vehicles in terms of cost or in terms of freight. So that's actually making a lot of reasons in order to make a commercial success of eVTOLs. So let me share my screen, or like Vyapak, you can share that as
Yeah.
well. So basically, in order to understand in a more better way, what we started doing, that we started mapping more than 500 companies, startups who are working on eVTOLs, trying to understand which stage they are in, what exactly their plan is, what the investment they have been able to attract, and what models they have been working on. And that's how we came up with the major ones that we have mentioned in the slide. Now, as I mentioned that like if you talk about major eVTOL companies, they have been showing a lot of rosy picture about the production rates. So, what we decided, we tried to understand market, across the value chain, because uh, if you talk about the raw material suppliers, if you talk about the tier players, if you talk about the other industry stakeholders, we also started taking their view, what exactly they think about the eVTOL productions and other things, along with obviously eVTOL manufacturers. And basically we did a lot of interviews across the value chain in order to understand how exactly eVTOL will take off from 2024 and onwards. So we did a really good number of interviews across value chain in different designations in order to get a really complete view of the market. And that's how we come up with our own analysis. So if you look at from 2009 to 2024, majority of numbers are is basically coming from Chinese OEM, which is EHang. So
Yeah.
if you talk about 2024, around 216 eVTOLs that they delivered, and rest three, one from Joby, one from Archer, and one from Autoflight. That's
Okay.
how it makes around 219. And if you talk about the other companies are very close to certification stage, and that's actually going to impact the overall deliveries in coming years. But what we believe that it's not going to be that rosy that it seems. Industry needs time, they need pilots, they need certifications, they need a proper solutions in order to make eVTOL a big success. And gradually we will see how the production will ramp up. So if you talk about 2040, we believe that in an annual basis, it's going to be around 2,200 eVTOLs are going to be delivered. And if you sum up, from 2025 to 2040, we believe more than 13,000 aircrafts or 13,000 eVTOLs are going to be delivered, which gives a really good view about the promises and the overall bright picture of this market. In terms of value, we believe that by 2040 the market could be around 3.2 billion US dollars. The reason being that it has a lower value, because if you talk about if you look at the current conditions, Chinese seems little ahead in race, and their price and the cost of eVTOL is much lower than that of Joby and Archer's one. So that's the reason, the value-wise market showing little slightly lower. But the fact is, the market seems really promising, and it will increase with time passes the moment more companies take place into account. Let's understand more about how this thing will, what's the current picture. So if you talk about in terms of configuration type, like multi-copter, as I mentioned, that majority of EHang delivered around 216 eVTOLs in 2024. That makes their share around 98.6%. In terms of category, majority of them are the passenger one. Joby and Archer delivered for military purpose. And if we talk about configuration type, it's more about currently lower, but with time when Joby, Archer, and other companies that come into the main commercial production. So we believe 5+ seaters are going to be the major area of market category. In
Okay.
terms of region, China is currently dominant. However, this will change with coming years. So so moving down, like we already mapped what are the pre-orders that they have. So that clearly shows that the two major eVTOL companies, one is Eve, another is eHang, who have orders close to 2,005 or 2,800. Now Xpeng is another around 2,000. Then Archer, Elroy, Autoflight, Dufour, they also have really sizable pre-orders with them. And if you look at that, majority of them are likely to be certified between 2026 to 2028, and that's how the market will start evolving, and will have a lot of companies coming into the commercial productions. So this is about investments. Already, Mansur gave us really good view on that. A lot of investments being attracted over the time. But if you talk about the past 2 years, we see a pause in investment, and that's absolutely going to happen. Why? Because there are more than 500 companies, or somebody says that more than 1,000 companies. But the point is, gradually this is going to be, there's going to be consolidation, and ultimately 20, 30 companies will come and play a bigger role in the market. So this is a typical supply chain. The most important thing that we understand about the supply chain, that all the major commercial aerospace tier players, they started taking sheer interest in eVTOL business, and that's one of the key of this business successes. Why? Because they have a history, excellent history of producing a lot of systems, components, parts for commercial aircraft, and these expertise play a big role in order to make this dream into the big success. So if you talk about the avionics, all major avionics manufacturers, they already started taking sheer interest in eVTOLs, very similar for fuselage, very similarly for battery cells, propulsion system, wings, others, and that's how the entire supply chain is evolving. Now, let's understand more about the company-wise. So, like in case of Joby, they started working with Toray, the largest carbon fiber suppliers. Uh, they also get investment from Toyota. So obviously, they will get a lot of expertise from Toyota in terms of commercial production. Similarly, Archer, they have done a really multitude of companies in terms of strategic alliances, very similar for Eve, Vertical, AFT, Beta. Lilium already filed bankruptcy twice. Helicopter is already being bid by a Chinese company along with one European company. So that's going to evolve. Yeah, just a moment. Yeah. So this is the most important thing to understand. So as I mentioned that initially a multi-copter is a major category, that it's being clear that out of 219 units being delivered, 216 were multi-copter. Basically, Hang was there. But how the market will evolve in coming time, if you look at that, vector and lift crews are going to play a really good view or big role in the market. And if you look at the market in terms of value, that shows a different entirely landscape. So vector and lift crews in terms of value, they are going to have 80% plus share, or you can say that more than 85% plus share. Reason being that the value of these aircraft is much higher than that of the multi-copters. So that's how the European and North American companies will gain benefits with time. Currently, China seems ahead in the race.
Understood. Thanks for that, Mr. Agrawal. I'm very sure those projections definitely would help our audience to separate the signal for the noise from the noise. Now, let's talk about regional momentum as well, right? Initially, most in the industry expected North America or Europe to lead in certification and commercial rollout of eVTOLs. Because most of the eVTOL programs that are being run are mostly based out of these two regions right now. But we see that the tables have turned. China has clearly jumped ahead, right? EHang, right? Mr. Agrawal also mentioned right now, EHang has not only secured a type certificate but also a production certificate for its EH216S aircraft. And I was just reading news recently that they've also got operation certificate for passenger travel as well in March. 2 months, just 2 months ago, right? So, and also meanwhile, Autoflight is also making impressive progress. So, Dr. Chelimi, in your view, what were the key enablers that allowed China to outpace other regions in regulatory approvals? Was it a more flexible certification framework, strong government support, or perhaps differences in operational and business model priorities that we were talking about?
Yeah, Vyapak, you are absolutely right. China's emergence as the first mover in eVTOL certification and commercialization has shifted expectations in the global advanced air mobility race from North America or Europe to China. That's
Yes.
why China has demonstrated a unique ability to accelerate the path from prototype to revenue-generating services, particularly with players like eHang and Autoflight. And I think the key point is that their design is simple, as I mentioned before. The design of eHang is simple to be certified very easily. And
Okay.
it is targeted for the in-city urban air mobility. That's why it can be certified very easily. And on the other hand, the Civil Aviation Administration of China, they has taken also a more flexible and scenario-based approach for the certification,
Okay.
especially for non-piloted short-range vehicle like eHang EH216S. That's why instead of forcing eVTOLs to conform entirely to legacy fixed-wing rotorcraft standards like FAA and EASA forced those companies, CAAC adopted a special conditions for certification paths. That's why it's better aligned with eVTOL operational realities. That's why China, I think they prioritized safe enough to launch over perfect compliance, enabling controlled commercial deployment faster. Another thing is that Chinese governments actually they see the eVTOL as a structured infrastructure.
Okay.
That's why part of its broader push for smart cities, green mobility, and global tech leadership, they I think help those companies to certify their eVTOLs very easily. On the other hand, municipalities they are actively supporting pilot programs with
Okay.
eHang conducting test flights over dozens of provinces. They help actually they let them to fly over those provinces. And I said with eHang's two-seat autonomous and multi-copter style aircrafts, they have short range, like 35 kilometers, something like that, and they have fixed routes. I think all in all cities you should start with the fixed routes, like
Yes.
aerials shuttles, and they have low altitude corridors, and they don't have onboard pilots, and but they are going to track the aircrafts from the ground stations. And in any emergency case, they can intervene with the flights. And
Okay.
this reduced the complexity both in design and certification, and also in the operation phase. It can be predictable, it can be repeatable in the urban air routes. That's why it's easy to track them. That's why by choosing a simple and soon, I mean, in a short time, over complex and later, China OEMs, they reduce the risk and they speed up the delivery. But on the other hand, the Western companies, the eVTOL programs, they slow down due to lack of coordination between OEMs, regulators, governments, the infrastructure developers, and airspace managers. And it makes them to move much uh, in a in a slower phase. They create them to move in a slower phase. And
Okay.
on the, China, they had state-aligned integrations with synchronized progress across air certification, infrastructure deployment, and airspace policy. That's why they moved, I think, very fast.
Okay. Understood.
This
Also,
is what I understand. And when you look at, for example, Xpeng, I think Xpeng also will be very similar to eHang. Why, if they continue like that, they will be certified very easily. Although flight, their aircraft, I think it's still very heavy for me, and that's why it may take time for them to be certified. But eHang and Xpeng, they will be in a very short time. They can start their operations, air taxi operations.
yeah. Autoflight also has got type certification for its for one of its aircraft and is now waiting for operation certificate. Or production certificate. Pardon me, production
Production,
certificate.
yeah.
Yeah. Also, this reminded me of when I was going through the facts, investment facts. Right. Since you discussed about simpler designs, I'm asking this question.
Mhm,
Joby has raised around 2.98, approximately 3 billion US dollars of funds, right, for research and development.
mhm,
Archer is at 1.75 billion US dollars. Lilium had 1.45 billion US dollars before. Now they've shut the operations, right? But when I look at the numbers of eHang and Autoflight, they're significantly less, right? In US dollars,
Yeah,
it's just 260 million US dollars for EHang and 200 million US dollars for Autoflight. So, do you think this is also because of simpler design, or there are other factors into play?
I think definitely it is starting from the design. I mean, if
Okay.
you have a good, simple design to be certified, you don't need
Mm-hmm.
that amount of that much money for the certifications. And most of the people, they blame those certification authorities. They say that they don't have enough regulations for those eVTOLs. But
Mm-hmm.
I'm not agree with them, because you should first convince yourself that you have a more stable and reliable aircraft that can fly. If, as an OEM, if you are not believing in your aircraft that it can fly safely, then
Uh,
you cannot blame authorities. If you check those companies during, for example, some of the air shows, they ask those companies to come and to do some test flight shows, and no Western companies, they didn't show up,
yeah.
because they are not believing into their aircraft that it can fly safely, and the stability is not enough. That's why they, for the complex designs, you have a lot of time to go to be able to prove that they are actually flying safely and stable. Even we are just talking about the current in a good weather conditions. If you have bad weather conditions, high winds, high gust, in those cases, you should also test all the aircraft, because otherwise you cannot fly those aircraft. It's a matter of, I think, designing simple aircraft that can stand those all-weather condition flights. And if it is simple, you can be sure that nothing will happen. And the redundancy, creating redundancies, is very simple. And even if you have lightweight aircraft, you can put some parachutes for the emergency cases. I think authorities will make compulsory for most of the aircraft if you are flying over cities. And another one is crash avoiding systems. Crash avoiding systems, you should work together with the air traffic management systems, and
Yes.
all aircraft should have their protocols to be able to communicate with other flying objects, that
Yes.
in case of crash, they will avoid autonomously. Even for tall buildings, they can avoid crashing those tall buildings. That's why the protocols, the air traffic management systems, with a simple design, can make it quickly for the air taxi operations. And you said that Lilium, Volocopter, Archers, even Joby, they are going well right now,
Yeah.
but it may take time for them also to start air taxi operations in urban areas. In other areas, they can start, it's okay, but in urban areas, it may take time for them also.
Okay. Understood. Thank you, Dr. Chelebi. That really helps unpack what's happening in China. Thank you so much for that perspective. Mr. Agrawal, coming to you now. Once the eVTOL market matures and the global players are fully in the game, which region do you believe will dominate the industry in the long term? Because right now China is leading, but what's ahead once the industry matures?
So as even Musi was saying that it clearly seems that there are a lot of factors behind the success of eVTOLs. China's still ahead in the game. Vyapak, can you please show the slides once again?
Yeah, sure.
Okay. Just, yeah. So China still seems ahead in the race, driven by that. They already got early success. But what matters, I believe, is more about the long-term horizon. So it's not like that. The short-term horizon uh, gives us a one view. But I think the most important for industry is to look at 15 and 20 years down the line and how this system will evolve. And that's how a different entire regional perspective took place. So based on our estimations, like when we say that the eVTOL market in terms of regions, North America, Europe, China, rest of Asia Pacific, and rest of world. That's again in terms of manufacturing. What we believe that China will lead the overall production,
Okay.
but importantly, if you talk about the North America and Europe, they would be very close to that. Europe seems behind. Reason being that lithium, volocopter, both major European eVTOL companies, they could not get funding. Reasons already being shared by Dr. Mansur. So we believe that Europe seems little behind, but
Okay.
North America seems to be really good in if you talk about the next 15 years down the line. And there are a lot of reasons behind it. One reason is that the kind of area that they have been working on is more about which actually make them to develop vehicles that could lead to $3 to $5 passenger per mile,
Okay.
because they are working on five-seater aircraft, and when you try or when you bring that into success, so these aircraft may help to because they have large passenger capacity, they help them to reduce passenger mile per mile cost. Also, like if you talk about, their designs are more robust. Like if you talk about the long-term horizon, obviously, the certifications may take more time, but once they get the certification for both, like including the production, so they may get really good success. And
Okay.
most importantly, the U.S. Defense has been actively, taking interest in eVTOLs. And that's the reason, if you look at the early orders or early deliveries of both Archer and Joby, it belongs to US Defense. So
Yes.
US Defense, as even Mansur said that for passenger, for urban air mobility, you need a lot of time, you need to address a lot of pain points. But in case of government or defense side, it's relatively easy to supply and start delivering that one. So that's give a very good view that in long term North America is going to have a really good eVTOL production. And if you look at again, I said there are two perspectives. One is in terms of units and in terms of value, and industry is more about what's the value ultimately being produced or being delivered in different regions. So if you look at in terms of the below table that we created, that tells us entirely again different picture. North America is going to be more than 55% in terms of value by 2040. Whereas if you talk about in terms of units, is going to be 30%.
Okay.
So that gives a very clear view that in terms of value, we believe North America is going to be a bigger market by 2040. Uh, Europe followed by Europe, and then after China. Being reason that currently majority of the success is more about low cost eVTOLs. So this what we believe that So, but undoubtedly, the role of China is going to be very important.
Okay.
They keep producing a really good number of aircraft or eVTOLs in coming years. So in terms of unit, we believe that they are going to be more than 1,000 by 2040. But in terms of value, is going to be lower. Reason being that the eVTOLs being produced by companies like Joby, Archer, who already got early success, so their price is much higher than that of EHang and other ones.
Understood. So China is expected to remain important, but not the leading one as the market matures.
Yes.
Thank you. Thank you so much, Mr. Agrawal, for the beautiful insights that we've got here. Uh, Dr. Chelby, before discussing the last question, we've got a very interesting question in the comments. Since we were discussing about simple and complex designs, right? You spoke about simple designs, and now Mr. Agrawal spoke about the benefits of complex designs in the longer terms, in long term, right? So here we have a question on LinkedIn. Aniket asks, Dr. Chelby, do you think the choice by OEMs to resort to complex designs rather than simpler designs is also a part of protecting their intellectual property? I mean, designs too similar could lead to possible IP infringements.
I don't think so, because simpler design doesn't mean that it is easy to be copied.
Okay.
We have, for example, Jetson One company. They already sold over 200 design. To I think even close to 400. They have some orders. And why don't you copy those aircrafts? It's not so simple actually to copy them, because it's not just what the size is not so important. The subsystems like flight control system and their stabilities and the other subsystems that you use during the flight, it's very important. That's why the simpler design doesn't mean that actually you can copy it very easily. EHang, for example, they have 8 rotors or 12 rotors compared. I mean, they have different models, and some other like AirCar, they have 8 rotors. But for developing those aircraft, it takes almost 6 years or 8 years to just develop and to make sure that they can fly safely, they can fly stable, and their flight control softwares and all the redundancy systems. That's why I think it's not so simple to copy simpler designs. But on the other hand, why do they make those complex designs is a good question. I think they approach from the luxury point of view. Like they want to make it similar to helicopters. There are some luxury helicopters
Okay.
with the 4 passengers, 6 passenger flights for the long range flights. They think that the investment will be much higher in those designs. But initially, yeah, they got some attentions from the investors. But later on, when the certification period it gets longer and longer, and they need to hire more people for their employees, then it's run out of their patience of the investors.
Okay.
That's why I think some of companies they may pass those levels with the enough funding, but the others will fail to do certifications.
Okay.
But it's a good question, Aniket.
Yeah. Thank you, Dr. Chelby, for that answer, and thank you, Aniket, for that question. Also, viewers, for viewers watching us live on LinkedIn, please make sure to drop your questions on LinkedIn live comments, and we will try to get answers from Dr. Chelby and Mr. Agrawal. Now, moving on, Dr. Chelby, let's now end on a question that goes straight to the heart of eVTOLs as it concerns the masses. Right now, we were discussing about you know it being a mode of transport or it being a luxury, right?
Mhm.
So, different OEMs like Archer, eWare Mobility, they projected that eVTOL fares could eventually drop to around $3 to $5 US dollars per person per mile, putting them on par with the premium ground transport, like say for example Uber Black, right? So, from your expertise, does this cost target actually sound achievable to you?
Actually, it's a good insight. When we first tried to design our air taxi, we were also focusing on the $3 to $5 per passenger per mile targets. It
Okay.
is I think it is the most critical threshold for the viability of urban air mobility. If you have the same amount of transportation costs with the air mobility, then you will prefer to use air mobility. But
Totally.
achieving this $3 to $5 per passenger per mile, it's not. I think in the early years of service, it's not possible,
Okay.
and it depends on the fleet scale, the load factor, the utilization, and most importantly, the cost per flight hour. That's why I think again the simpler design makes it effective to be able to have this amount of $3 to $5 target to be able to reach these targets. Because similar to ride share economics, like cost per mile drops with the high throughput, and in that case, the eVTOL need to fly 8 to 12 hours per day. Not to if you fly with 3 to 4 hours, it will not be enough to get all those maintenance and other costs. And EHang, for example, they started with autonomous flights. That's why removing the pilot's salary, and while you remove the pilot, it means that you can carry more passenger, and it lowers the cost again dramatically. And also, vertiport turnarounds must be very fast and automated. And
Yes.
with the less ground operations, you can achieve those costs. Even the predictive maintenance, battery swapping, fast charging, it is critical for uptime. That's why the standardized platforms will reduce the cost of parts, training, and inspections. And if you were able to standardize all those flights and with the simple design, less cost operations, then you can reach $3 to $5 a passenger per mile. Otherwise, it will be very difficult. That's why I think, in short, I think optimizing aircraft usage, automated workflows, and standardized routes and infrastructure will let us to achieve these prices, and it will be publicly available for everybody to be able to use those eVTOLs.
Okay. Also, Dr. Chirami, what kind of timeline are we looking at before that level of pricing could become realistic? Do you have a timeline in mind?
I think with the EHang, if they start their operations, and I see that their design is simple, and if they can collaborate with the government and with the standard world ports and air traffic management systems, and then it can be reached very quickly. I mean, it can start immediately after you start operations. But public acceptance is also very important. I mean,
Yes,
it
complete.
should be operating 8 to 12 hours a day at least. That's why if people start to use it, the cost will drop very easily. And I don't think after certification and operational certification, it will take much time.
Okay, understood. That's a really interesting take. Dr. Chelabi, that was, however, the last question, but we have an interesting question down in the comments of LinkedIn. We'll just have a look at it. Greg asks, by what year do you think automation in the manufacturing process will enter the eVTOL industry, and what kind of volumes do you think the industry will be able to produce annually without any automation?
Yeah, it's also a good question because
Yes,
without any automation, it means you will manufacture manually, and
yes,
if you use thermosets, it will really take time to manufacture in high volume.
totally, yes.
But Deepak already showed some number of manufacture of eVTOLs by the year 2040. It's around, I think it's more than 3,000 or 4,000, around something like that. In that case, just using thermoset and without automation, you will not be able to manufacture those amounts. Maybe multi companies, they need to manufacture those number of volumes. And I also believe that once you just certified and you started operations in almost all around the world, people will ask to operate those air taxi operations, and that's why the numbers may increase substantially.
Okay.
When the safety and the regulations are standardized and people acceptance will increase, then the number of volume per year may pass maybe 10,000 or 50,000. I don't know, but it depends just public acceptance. That's why the automation is very crucial. And in
Okay.
that case, you will need to skip from thermoset to thermoplastics, like press automations, AFP automations, using robots to manufacture those parts. And just manufacturing is not enough. The manufacturing and then integration of those parts. And after that, also the repair procedure is very important. I mean, in case of crack, you need to repair those parts. With thermoplastic, it's much easier to repair the eVTOLs.
Yeah.
And by what year, if you ask the year, I think it depends on when actually those eVTOLs will be certified and it will widespread. Then it will go very quickly, the automation. That's why I said that you don't have to enter the eVTOL as an OEM manufacturer. instead of that, there are a lot of gaps to be able to be filled, like repair procedure, like automations of eVTOL manufacturing, those kind of things. You can actually, some companies may focus on those areas.
Yes, there is an entire ecosystem ready to be explored.
Just
Yeah.
to add one more point, so like if you make even from thermoset composites, so it's okay. Like if you are making from like if you're making prototype, that's completely fine. You can make it manually. But the moment you start, making one or two or three aircraft
Correct.
in a month, you need automation for even thermoset composites too. So like the processes like AFP, ATL are essential in terms of manufacturing fuselage or other crucial parts for made of the composites. So automation remains essential for thermoset as well as thermoplastic composites. Yes, agreed. If you talk about thermoplastic composites, it's going to be more beneficial. Reasons being that it's very easy to repair, it's recyclable, it's more sustainable, and importantly, that gives a lot of design freedom to companies.
Yes.
So automation, I believe, if you talk about in terms of here, the moment companies like Joby or Archer, like who already started delivering some aircraft, the moment they exceeding more than 5 or 6 aircraft, they need automation. So they need AFP, ATL processes. So that's the reason, if you look at the tier players like Leonardo or FACC, who are coming and playing a big role. Why? Because they have already all these processes with them. They have been working with Boeing, Airbus, making a lot of parts using these AFP and ATL processes. So they are going to play a big role. They are going to use these technologies, basically learning the experience that they have from commercial aircraft and implementing into the eVTOLs. So automation is going to be, in near future, when the company started manufacturing more than 5 or 6 aircrafts in a year.
And
5%.
Deepak, let me add one more thing. It's actually good insight that you mentioned, because from the authorities' point of view, they need you to manufacture each time with the same standard aircraft. I mean, when you manufacture a part, it
Yes.
should be traceable. It should have the same quality, same standards. That's why automation actually makes them to produce each time the same quality products. That's why it's very important. And I think currently all the commercial aircraft are manufactured, although they use thermoset, they use automated processes.
Correct.
Yes.
Agreed.
That's exactly the point of issuing type certificates
Exactly.
to
Yeah.
ensure the quality. Yeah. Now we'll move on to the next question. That was a brilliant question, Greg. Now we'll take another question. Thank you, Dr. Celebi and Mr. Agrawal, for the response. Now, yeah, taking another question. Which business model do you think can be more profitable for eVTOL OEMs? We have Joby on one hand, which is planning to have its own air taxi network, and then we have other OEMs that are fundamentally only planning to sell their aircraft to airlines. Now, that I think that's also a brilliant question.
I think if you let me answer the question.
Yeah.
Uh, for most of the eVTOL OEMs, they want to develop their own air taxi network, because it will generate more cash compared to selling the product to other operators.
Okay.
It's not so expensive to manufacture one eVTOL. I mean, an air taxi. That's why selling them will not be very profitable. But
Okay.
if you operate it with like $3 to $5, or initially it will be much higher. In that case, operating your air taxi network will be much profitable. That's why most of the eVTOL companies, I think they will prefer to have business model just to have their own air taxi operation networks.
Okay. Do you have something to add, Mr. Agrawal?
So completely agree with Mansoor. However, I believe both options have their own benefits.
Mhm.
If you talk about a business model like Chobi, who wants to play actually across the value chain and want to basically, this model helps them to make money in a longer term. Why? Because if you talk about the services, services is going to be the biggest revenue generating category
Okay.
once everything is going to be in place. So, and if you start keep manufacturing, ultimately you are going to have lesser profit. So that gives a very clear idea that why job in other companies are very much aligned in terms of not only just manufacturing but also offering services. But if you remain intact just on manufacturing, again, it has a really good advantage. Why? Because you keep working a lot on your product, on your eVTOL, keep advancing it, making it a really worthy product for the industry. So again, I believe both have their own advantages and disadvantages. But correct, companies who are offering along with aircraft and services much must be on a better profitable side.
Okay.
And I think that's why airlines should start to cooperate with eVTOLs right now. It's a good time for the
Yes.
airlines to do partnership with the eVTOL manufacturers and also airports, maybe operators. The airports also can do the partnership with those eVTOL uh, manufacturers.
Just like Dubai International Airport has partnered with Joby.
Yeah,
Yeah.
correct.
Yeah. Just recently.
Mhm.
Uh, Thank you, Dr. Celebi and Mr. Agrawal, for answering those questions. And I also want to tell our audience that if you want any have any other further questions, you can directly reach out to Dr. Celebi and Mr. Agrawal on LinkedIn. I hope
Yeah,
I hope that will be fine.
yeah, it's okay. Anyone can reach me via LinkedIn. And one last word, maybe, recently there's AI technology is developing very fast. And
Yeah.
I believe the AI technology can be also adapted to the navigation and crash avoidance systems of the
Yes.
eVTOL industry. That's why it may cause the authorities to certify those aircrafts very safely. I mean, they will believe that if AI involved in those areas, even air traffic management system, it cannot be run it cannot be run manually. That's
Yeah.
why if you use AI in air traffic management system, crash avoidance system, navigation systems, when thousands of air taxis flying above cities, it cannot be operated manually. That's why AI, I think, might be a crucial point technology to be involved.
I think in systems, I mean, in jumbo aircrafts like Boeing and Airbus, they have systems called TCAS systems, right? Traffic collision avoidance
Yeah,
system.
yeah,
You're talking about
exactly,
systems like that, but for eVTOL network, which would be much more dense in the air.
exactly. Yeah.
Thank you so
Okay.
much for those
Thank you.
insights, Dr. Chelabi. And with that, we come to the end of today's session. I really think this was a very meaningful and productive conversation. I hope you two had a good time, sharing your thoughts, Dr. Chelabi and Mr. Agrawal.
Thank you very much. Thank
Yes.
you. It's a
Thank you.
pleasure also for me to have a very good discussion with you.
Thank you very much.
Yeah, sure. And we'd love to have more of such sessions with you in the future, Mr. Agrawal and Dr. Chelabi. Right?
Okay. Thank you.
Yes,
And
sure.
Dr. Chelvi, as you mentioned about the panel discussions, at the beginning of this conversation,
Hmm.
we have initially started with only one or two guests at a time to ensure maximum
Hmm.
participation. But we would, highly love to organize such panel discussions in the time to come, and we would also like you to be a part of it.
Thank you. It's also a pleasure for me always to be part of your discussions.
Thank you so much, Dr. Chelvi. Thank you so much, Mr. Agrawal.
Okay.
All right, wrapping it up to both our speakers, Dr. Shelby and Mr. Agrawal, I express my sincere thanks for your time, your clarity, and for sharing insights that were both strategic and grounded in real world experience. It is indeed rare to have such a rich and multidimensional view of a sector, as complex and promising as the eVTOL industry. And also to everyone who has joined today, thank you for tuning in. Whether you are an industry insider, potential investor, or simply curious about future of advanced air mobility, we hope this session gave you valuable takeaways. Meanwhile, keep a track of our LinkedIn page to get notified in the future. Thank you everyone for connecting. Thank you.
Okay.
Thank
Thank you.
you.
Bye bye. Have a good day.
Bye bye.